Hello everyone, welcome back to HMATH space. And today, once we have finished about matrix, which is really important in the feed-forward network and also procedure, now we are moving on to another topic of math, which is multivariable calculus. And today's topic is going to be partial derivative. So keep in mind that this part is really important and it plays an important role, the main role, when we are considering backpropagation, which is the core process in AI and also deep learning, right? So originally we often work with a function that is a single variable like y equal f of x, and if we want to see what y changes when x change, then we just have to take the derivative of f of x, which is equal to the limit of h tends to 0 of f of x plus h minus by f of x over h. And this appears in elementary and also high school. But when we are working with real life problem, we often encounter this problem that is worked in 3 dimensions or 4 dimensions, like problems that are improving and also requiring a lot of contributing factors. And therefore, sometimes we are not just accounting for one variables. And this is where multivariable comes in. So for example, we have this plot right here that I have just thought here. So this is a function of z equal f of x and y, which is dependent on 2 variables, and this is equal to minus 007 x squared plus minus 007 y squared plus 3. So now that we look into this problem, we see that a slope of a point is dependent on 2 directions. So now you can see that when x changes, then z changes, and when y changes, z also changes. So to describe how z changes, we must describe how z changes when each of these variables change, and this is when it comes to partial derivative, right? So when we fix the x and then we vary the variable y, then we have the partial derivative of z over y, which is practically lim of h to 0 of f of, we keep the x constant, but then we change the y over h. And similarly, when we fixed the variable y and we varied the x, then we have the partial derivative of z over x, which is also the limit when h tends to 0, but this time we're moving the x but also keeping the y fixed. Right, so that means that when x changes, then z will change this much in the direction of x, and when y changes, then z will change this much in the direction of y. So we can take the following example, right? Z equal minus 007 x squared minus 007 y squared plus 3. So the partial derivative of x over x, practically we think that this part is constant, and then we just derive like normal, which is 007 times 2 times x, and then when we're deriving partially regarding to y, then we're keeping this part constant, and it will result in so practically the partial derivative describes the direction of changing of a point, and it must be expressed in 2 directions, or because the function is from 2 directions, right? So this is the end of the first video.